Good morning, friends. Welcome to the LABVIEW programming tutorials. In today's session, we shall move on to experiment 2, that is Boolean operations, logical AND, OR, XOR, NOT and NAND. Okay, so directly I'll move on to the tool. I'll launch the tool and I'll say file new VI, Control T in order to view the block diagram on front panel simultaneously on your window. Okay, so now we are doing experiment 2, that is Boolean operations. Okay, so now let me take if I say Boolean operations, what are the different possible inputs might I took? So of course Boolean switches, right? So Boolean switches, so the status of switch can be changed to 0 or 1. So right click on the front panel, go to Boolean container now, take the push button. If there are rockers, vertical rockers, horizontal toggle switch, any control can be taken. So push button is the simplest way. I'll call it as A. Similarly, go to new Boolean and take one more push button, call it as B. Okay, so now take the indicators in order to show the output of AND, NOT, NAND, XOR, some other gates as well. So I'll take round LEDs. This is for logical AND. Similarly, I'll take one more. That is for logical OR. Okay, so you can copy the indicator and you can change the name also. That's also possible. Okay, logical OR, then NAND, logical NAND. Similarly, one more output indicator for the XOR gate, logical XOR. Right? Fine. So now I'll be move on to the block diagram. Okay, in order to call the logical functions or the Boolean functions. So where will be the Boolean functions? Obviously in the Boolean container. Okay, so right click on the block diagram, go to Boolean, take A and D function. A and D is logical and give the label. Similarly, go to Boolean, take R. Before verifying this, I want you people to glance the truth table of all the basic gates. Boolean, exclusive R and logical NAND. So NOT and AND is NAND. Okay. Yeah. So now you connect the inputs. So similarly, I'll connect both the inputs to the okay. So connect both the inputs to the NAND. Similarly, connect both the inputs to the XOR. Okay, then connect the output XRY, not of X and XR. So this is the way of building the VI for Boolean operations. Okay, you can also explore other Boolean operations as well in the listed container. I am labeling all the logical blocks in order to understand them very well. and recall the functions that I know very well. Okay, so now my VI is ready. That will show the results of logical AND, OR, NAND and XOR. Okay, now I'll run the VI continuous mode, and of course at this point of time you could able to remember the gates and their function table or truth table, right? So if both the inputs are 0 0, only logical NAND will produce a result of 1, correct? So if I make my inputs 0 1, see this B indicates the 1 state now. 0 1, logical OR will be 1. Okay, logical NAND, if AND is 0 and the logical NAND will be 1. Logical XOR, of course different inputs are there, then logical XOR is 1, where logical AND will don't show anything or in 0 state. Now similarly I'll make A as 1 and B as 0. Same result as we stated, different inputs, XOR is 1. Since one of the input is 0, logical NAND will going to be 1, and 0 plus 1 is logical OR, and we are left with one combination. Both the inputs are 1. I'll make both the inputs are 1, logical AND is 1, logical OR is 1. Since AND output is 1, your NAND will be 0, and since same inputs are available at the input and the parity gate called as XOR will leads to 0. So this is how the Boolean operations can be understood by simulating the VI of Boolean operations. Hope you understood. Thank you.